Hi girls, sorry I'm not in class today, but if you watch this video you'll be able to finish some pages in your noties and then be able to do some stuff from your textbook. So last time we were talking, we're on page 4 of our noties, and we talked about raising to a negative power. Okay, following that comes another thing called fractional indices. We're going to skip that and go to the last section, which is on page 5, called standard or scientific notation. This is what we're going to fill in and do some examples from our textbook. So very large numbers that are greater than 1, or very small numbers that are fractions, so less than 1, these numbers can be represented using a product, which is something times by each other of a number between 1 and 10 and a power of 10. So this scientific or standard notation has two parts. There's a number between 1 and 10, there's a power of 10, and you multiply them together. For example, 340,000 is just an ordinary number, but it can be written in this format, which is the scientific notation format. 3.4 by 10 to the 5. So 3.4 is a number between 1 and 10, and 10 raised to the power of 5 is a power of 10. So we write it like this: 3.4 times by 10 to the 5, but we say that is 3.4 by 10 to the 5. So write it one way, say it another way. So 3.4 by 10 to the 5. So that's a product of 3.4 and 10 by 5, or 10 by 5. What's the number between 1 and 10 in 3.4 and 10.5? Well, that is obviously 3.4. It's greater than 1, less than 10. What's the power of 10 in 3.4 by 10 to the 5? Well, 10 raised to the power of 5 is the power of 10. And we know that means 10 times by itself 5 times. Here's some other powers of 10. 100 is 10 squared, 10 by 10. 1,000 is 10 cubed, 10 by 10 by 10. And you'll note that 100 has 2 zeros following the 1, so it's 10 squared. 1,000 has 3 zeros following the 1, it's 10 cubed. 10,000 on the hand has 4 zeros after the 1, so it would be 10 raised to the power 4. 10 raised to the power 6 would have 1 0 and 6 zeros following a million. And this one, which has 3, 6, 8, that's 8 zeros, that's 100 million. That would be 10 raised to the power 8, because it has 8 zeros following the 1. Now here's the idea of using this scientific notation for large numbers. Okay, it gets very boring after a while if you had to write 496,000 million every time that you wanted to do it. But you can do it in a shorter version using this standard form. You want a number between 1 and 10 and a power of 10. So the first thing, the decimal point is after the last 0. So let me just rewrite this again. 946. 1, 2, 3, 4, 5, 6, 7, 8, 9. Now the decimal place is after the last 0. Now the idea is that we move the decimal place so it is after the last after the first non-zero digit. So here's the decimal place. I'm going to move it after the 9, because the 9 is the first non-zero digit in this number. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Now, it's important to count the number of jumps that I made. So, now that I moved the number after the 9, what's the first non-zero digit here? Well, it's 9. And now by moving it, what's the number between 1 and 10 that I formed? Well, that would be 9.46. Okay? Includes all the digits which aren't zeros. How many places did we move the decimal point? We moved it 11. So what will be the power of 10 in my standard form? It would be 10 raised to the power 11. 11 jumps, we multiply by 10 to 11. So what's the number in standard form? Well, we need the number between 1 and 10, that's 9.46, and a product of it, so we multiply by the power of 10, which would be 10 to the 11. So once again, write your number down, go to the decimal place right at the end, move it jump-wise until it's after the first non-zero number, non-zero digit. That'll give you a number between 1 and 10, and you count the number of jumps. So you write down the number between 1 and 10 and times that by the power of 10, raise the number of jumps that you moved it by. Let's do this example over the page. 41,000. So I'm just going to write 41,000 out here so I can play with it. Now the decimal point is after the last zero. We want to move it so it's after the first non-zero digit, which is the 4. So I'm going to move it 1, 2, 3, 4 places. So then I'm going to rewrite it as, now what's the number between 1 and 10 I formed? 4.1. How many places did we move the decimal point? 1, 2, 3, 4. 4 places. So I'm going to multiply my 4.1 by 10 to the 4. 10 to the 4 because I moved the decimal place, 4 points. Okay, what about 257,000? 257,000. Okay, the decimal point is after the last 0. Okay, I'm going to move it to the left, so it's after the first non-zero digit, which is 2. So 1, 2, 3, 4, 5. Okay, I've made a number between 1 and 10. That's 2.57. I'm going to multiply that by 10 raised to the power 1, 2, 3, 4, 5 by 10 to the 5 because I moved the decimal place 5 positions. Okay, so that's taking a normal number and changing it into its standard form or scientific form. Here's the other way around. I've got some numbers in their scientific form or standard form. I'm going to write them as normal numbers now. So, express the following as ordinary numbers. 6.74 by 10 to the 4. Now, we move the decimal point, the number of times the power is raised, power of 10 is raised to. So I want to make a big number. So I want to start with 6.75 or 6.74 but end with a big number. To do that, I'm going to move the decimal point to the right. So that the decimal point is after the 6. But to make a number bigger than 6.7, I'm going to move it. And I'm going to move, in this case, how many places? 4. Here we go. 1, 2, 3, 4. There's the new decimal point. Now, it's jumped over the 7 and 4, but I've got 2 spaces here. What do I do with those spaces? Well, I fill them with zeros. So 6.74 by 10 to the 4 as an ordinary number is 67,400. Again, take the decimal point, move it the number of places that 10 is raised to the right. That's the new position of the decimal point. If it jumps over spare gaps, we fill them with zeros. Next one, 5.05. Okay, and it's by 10 to the 8. So how many places do I move the decimal point? 8 places. How many, or what direction do I move it? Always to the right to make a big number. So I'm going to go 1, 2, 3, 4, 5, 6, 7, 8. There's the new decimal point. So it's gone over the first 2 numbers, or 2 digits, 0 and 5, and it's got 6 gaps afterwards. Fill them with zeros, and then write it out properly again. So that would be 505, and then 6 zeros after that. So that is 505 million. All right. So we can use this scientific notation to simplify very large numbers, but we can also use it to simplify very small numbers. Like in this next example, I've got 0.00543. That's a number way smaller than 1. And I can get much smaller numbers than that with lots of decimal places. And if I had to write it out again, it'd be very boring if I had to do it all the time. So we use scientific notation for numbers like this as well, very small numbers. Again, the decimal point is after the first non-zero digit. Sorry, is after the first 0. We move it so it's after the first non-zero digit. So that means I want to take, for example, this number, 0.00543. And I'm going to move the decimal point, which is there at the moment, so that it's after the first non-zero digit, the 5. So 1, 2, 3. So there's the new position for my decimal point. Okay, so that has formed a number between 1 and 10. Okay, what is the first non-zero digit? Well, they're all zeros except when we get to 5, so that's 5. And when I move the decimal point after the 5, it's now made a number between 1 and 10. What is that number? 5.43. How many places did I move the decimal point to put it after the 5? 3 places. Now, here's the thing. Because this is a small number, 0.00543 is less than 1, the power of 10 that we multiply our number by, between 1 and 10, we make that power a negative power. So what would be the power of 10? Well, we move the decimal point 3 places. But because this is going to be a small number, we raise that 10 to not 3, but negative 3. That's the power of 10. So what's the number in standard form? So the number between 1 and 10 is 5.43. We times that by the power of 10, times by 10 to the 3. And again, it's raised to a negative power. That's 10 because this is a small number. Alright, let's try these ones. Small numbers, all less than 1. Let's write them in standard form. Okay, 0.035. Now there's the decimal point. I want to move it so it's after the first non-zero digit, which is 3. So I'm going to move it 1, 2. Okay, that's going to make a new number between 1 and 10, 3.5. How many places did I move the decimal point? 2. I'm going to raise the 10 to 2. But, again, because it's a small number, that 2 is actually going to be negative 2. So that's 0.035 in its standard or scientific form, 3.5 by 10 to the negative 2. And the next one, 0.0071. Okay, there's the decimal point. We're going to move it till it's after the first non-zero number, which is 7. So 1, 2, 3 places. There's the new decimal place. Okay, the number between 1 and 10 is 7.1. I moved the decimal place 3 places. So I'm going to times it by 10, raise the power, negative 3. Again, negative 3 because it's a number smaller than 1. Alright, and the last bit, like we did previously with the big numbers, how about I have some small numbers that are already in their scientific notation, and we're going to write them as ordinary numbers. So the first one, 3.9 by 10 to the negative 2. So we start with the number between 1 and 10, which is 3.9. Now I'm going to move the decimal point. Where do I move it to? Well, I'm going to move it 2 places. But because this time that's a negative term, I'm going to raise it, I'm going to move it that number of times to the left to make a number smaller than 1. So 3.9 by 10 to the negative 2, I'll move the decimal point 2 places, but to the left. 1, 2, there's the new place. What do I put in this gap here? Of course, a 0. So this 3.9 by 10 to the negative 2 is 0.039, and it would just look neater if we put a 0 in front of the decimal place, so it looks like that. Okay, that's a number between 1 and 10. So that's a number less than 1, so I know I've gone the right direction. I've moved the decimal place to the left to make 0.039. That's what 3.9 by 10 to the negative 2 looks like as a normal number. And the last one, 5.09 by 10 to the 3. So we're going to write out 5.09. There's the decimal point. How many places will I move it? 3 places because it's 10 raised to the negative 3. I'm going to move it to the left. So that's 1, 2, 3. There's the new point. And in these 2 gaps here, I'm going to put some zeros. So let's just write it out better. That's 0.00509. We'll just put a 0 in front to make it a little neater. So 5.09 by 10 to the negative 3 is 0.00509. Alright, that will do us for today. Thank you for listening, girls. Now, you should be able to go to exercise 6F in your textbook and try these numbers, all on scientific notation or standard notation. Questions number 4, number 5, number 7, and number 8. So for all of them, just do a to F. So just do A to F in each of those numbers. Okay, number 4, 5, and 6. Number 4, 5, 7, and 8, A to F, all of them. Okay? Now once you have completed them, you've got an opportunity to work on your assignment or your homework sheet, which is due tomorrow. If you've lost your homework sheet, then you go to our Canvas page. There's a folder there which says homework. It's in there. You can print it off from there. All right. Thank you for listening, girls. Good luck tomorrow.